third speaker will be Dr. Muneer Bakhsh, CEO of GDC Middle East, who has a rich experience in the aircraft industry, who will be delivering his talk on the carbon fiber in aircraft industry.
So today I would like to talk about the carbon fiber in aerospace industry. And I'd like to thank everybody who made this happen. It's a great opportunity to be here with everybody today. I'm going to touch base on multiple things from the industry point of view, from from the industry side of things, not from the industry side of things, and actually designing composite material in the aerospace industry. From materials, I'm going to touch base a little bit in materials, since the gentleman, the professor before me, went really pretty deeply in the material part of things. I'm going to be more into the design, manufacturing, and assembly part of things. All right. So today, from the design point of things, we have for the thermoplastic, thermosets, and DLF, which is a discontinued long fiber. As an engineer coming from the design, composite aerospace design industry, we, as a designer, we look into designing structure parts. So when we look at, when we start designing our parts, we start looking into what kind of materials we're going to utilize, given the fit, form, and function. This is for three important things. We'd like to, we look into the form of the material, what kind of material we're going to use. We look into the function of the material, how the stress analysis, how we're going to use it, and then the functionality, how it's going to function under heat, pressure, altitude, and so on. So in aerospace, we look into multiple, actually many elements to design a structure, aerospace structure part. So when we start designing this kind of structure, we utilize tools. We have tools like CATIA, FiberSim, and there's many other design tools like even SolidWorks and simulations out there in the industry. These kind of tools support us and help us in how to form and design composite parts. Now, with designing composite, as many of you know, it's pretty challenging to design just any part. Coming from the metallic world, going into the carbon board, into composite world, is pretty challenging. So we have to understand the strengths and the stress analysis, the stiffness, what we need to design the part for structure analysis, for structure or non-structure or secondary structure for aircraft. So given that elements or these boundaries, we start looking what kind of materials do we need to use. So widely used in aerospace is a thermoset material. So we already have the mechanical property and we know how to form it. The interesting part about composite is you really have to understand the manufacturer part of things before you start designing it. A little bit unlike the metallic board. The metallic board, we used to go and design the part from a bulk, and we start making it. Choosing the aluminum 2024, 7075, or titanium or steel. With composites, it's a little bit different. We have to really go through what kind of material to use, and we have to understand how we're going to manufacture the part, not just how to design it. As a designer, we can't design anything, but can we manufacture it? So when composite, you really have to understand, have a good idea about how you're going to manufacture it and what kind of process you're going to utilize to design your part. It's very important. So we have multiple tools in the design, like FiberSim, Abacus, Patra, and Nastran for simulation and stress analysis. And that's really kind of give us with the advanced tools today, we have utilized how we are really projecting how to see the part after we're designing it. So we can have these tools to help us how we're gonna manufacture. So we have such a hand layup. Very important to know: are you gonna design the part utilizing the hand layup, which is the traditional way, or automation? With automation, I'm gonna go more for the next slide about the factor in the kingdom about automation. Now, we have to also keep in mind the process. Process is very important. Are we doing it high fusion, compression molding, Vartum, Capri, RTM, high fusion, diffusion, compression molding? All this process is important because it will affect the strength of our parts. How we're going to design this part, and will affect the strength of it also in different environments. As you all may know, I mean, composite materials been out in the industry for decades. So it's not a new thing. However, we are improving as time, as new technology coming out and new materials coming up. So we have to keep that in mind. What kind of process we are using to manufacture a designed structure part? Keep in mind the fit, form, and function. Those three elements are very important to come up to the optimum and ultimate part. Then we come to the assembly part of things. It's very important to utilize our jigs and tools, collaboration, the kind of tools. For example, in composite, when you do a hand layup, you can't lay it up in steel or Kevlar or better composite tools. So your thermal expansion would not be a big problem. So back to a design engineer, it's very important to keep up with all these elements. Your design, your material, how you're going to design it, how you're going to manufacture it, and how you're going to assemble it. There's also a very good elements to it, which is a repair. How you also going to repair it? So as a design engineer, you got to keep in mind how you're going to bring all this together. So with the assembly, it's very important to watch out for your engineering tolerance buildup, the assembly, the installation, and then you have the final product. And then you do the stress analysis on the assembly and sub-assembly. That's another aspect of designing a composite structure aerospace part. We have laser technology where we do the laser pointer and laser projection to help us with the assembly and come up with the right tolerance. And we need sometimes tolerance engineering to start calculating that, because as you may know, in the aerospace industry, when you're building an aircraft, tolerance buildup could be a very challenging to keep up with. Also, the tools that we use sometimes for this is clash analysis, utilizing CATIA and many other tools. I guess keep putting CATIA because I utilize that myself. But it's very important to make sure that you are within the tolerance of your buildup, because very important. It will definitely affect your stress analysis if you do not account for your tolerances and your gap and step for aerodynamics, for example. So this is a little bit about design engineering and manufacturing assembly. So repair is also a very important element. You have to account in your design how you're going to repair the part. It's going to get hit. It's going to be damaged at one point in time. There are some parts that really for composite, you really don't need to repair it to just replace it. But when you think about a skin of a wing or a fuselage, it comes fairly expensive to repair it. So we came up with some repair tools, and that's a very challenging issue with composite repair. Sometimes you really have to rely on, believe it or not, we utilized titanium sheets to bring out the strength of the part. So repair is not just like if you have a dent or something where you broke the fiber continuation on your part, on your structural part especially. You need to bring it back to its structural integrity. And since it's a composite part, the bigger the better to make the part. It's tough to repair it. So we utilize at one point in time we utilized titanium, thin sheet titanium, so we can make sure the structure integrity back. It's not just a dent and you just fill it with resin and you fill it with fiber and you scruff it and it looks good. That doesn't work in structural part, because you are already when a composite part gets damaged, you're breaking the fiber, and thus you will discontinue the load in the part. So we have to go to the titanium piece to connect it with fasteners so we can have a continuation of the load. Now, this is a brief about design engineering and composite design in aerospace and structure. As an industry guy, no longer an engineer in the design part of the world, but now as I moved into the industry part of things, I'm coming back to Saudi Arabia after almost 30 years in the US. Now I'm more into the industry. And the Saudi market, we really giving a huge attention to the composite technology. From the material part of things, as you heard from SABIC and from Aramco, my colleagues discussed about the material progression and the R&D they're doing, which is a great thing to see. Also, as you know, for the aerospace, we're looking at a different grade. We're into T800 and up, T700 in some location, but T800 that I worked with most of the time because I was designing a primary structure. So with the T800, I don't think it's yet there in the kingdom. Only a few companies in the world, I believe, they can provide this kind of grade of material. But inshallah, it will come to that. But the T800 is really the most preferred grade for aerospace structure parts. Now, having also said all that, and having said all that, and talking about the materials and the technology that we mentioned in the past, I'm going to go into in my next slide about what did the kingdom do under the Vision 2030 to start utilizing or working with composite part. Composite strategy and the factory that being built in the kingdom is really a cutting edge factory. This factory is over 27,000 square meter. It has all kind of machines to make composite structure parts. I'll start with the first one. There's an AFP, automated fiber placement, 1/4 inch, 16 toes. This kind of machine is capable of making a section of fuselage. It's a 9 meter in length, and it's utilizing unidirection UD tape to make a section of fuselage, or any round or oval or even semi-square shapes. The second machine is the ATL, automated type layup machine. This machine is capable of making up to 9 meter wing size skin. Also, there's other tools that we can manufacture spars and other structural parts in the factory. We also had NDTs, non-destructive testing machines, echo transmission, utilizing water, as you see in the bottom of the screen, to inspect a piece, the composite part. Also, there's a milling machine, a mill tool. Also, there's a Torres tool, which is really interesting. As you know, when you manufacture a composite part, you use a lot of tools. You use drilling and cutting tools. You need the autoclave tools. You need layup tools. So all these tools, it's a cost. It's very costly. This technology, which is called Torres tool, it will really confirm to your part. So you need one tool, it does it all. So you do your layup in that tool. You can autoclave it. You can cure it in that. You can cut it and drill it also in the same tool. So you're really cutting costs by using one tool rather than a lot of tools. Also, there's an autoclave, 10 meter long by 7 meter diameter, autoclave for curing the composite part. And when I say composite carbon fiber, it's really thermoset. If you want to go to a thermoplastic with these machines, you got to chain the head and do some modification to accommodate for thermoplastic, but it's not there yet. I think as a business need more for thermoset. Now, this project, the objective of this project is really to bring the most advanced manufacturing composite part technology to the kingdom, to Saudi Arabia. Also, with the plan for this factory, there's a growth plan to become one of the largest factories in the Middle East. And also, with this factory, obviously, we need capabilities. We need to develop the capabilities to manufacture all different kind of parts, civil, military, and even UAVs, even other parts, not just structure for aircraft. It can be for anything. If you design it, then program it, and you can make it. So this is kind of a brief about the factory that is in the kingdom, utilizing carbon fiber thermoset part. This is the layout of the factory and the equipment in it. As I mentioned, the green area is 30 meter by 8 meter by 80 meter, 14 meter height. On the right-hand side of the blue is the AFP automated fiber placement. It's up to 9 meter in length. It can produce any circular, oval shapes. Then the next to it It's ATL in the red color, which is automated tape laying machine. It's capable of making a wing up to 9 meter, a wing or empennage, vertical, horizontal, any curve or semi-curve shape, not complex shape. In the far left side, upper corner, in the green area is the yellow. With the yellow oval, it's a cutting machine. It's for cutting carbon fiber or cutting the material. As you go down the factory, by the way, the blue area, the blue light blue area is the workflow. As the part comes from the freezer, you see the middle gray area. There's freezer. You take the material to the clean room. The clean room is within the specification of most of the OEMs ISO standard. So it's you have to control temperature, you have to control pressure, you have to control pressure, temperature, and particles for cleaning. So it's a positive pressure inside the clean room to push any dirt or any sand or anything outside the area, so nothing comes in, because it has to be very pristine in order to make a composite part, as you may all know. It has to be very, very clean area especially at this build-up time. Then it goes through the blue area down to the right-hand side. There's the autoclave, the one 10 meter length by 7 meter diameter, and then go to the left, which is the green area. That's an mill tool, which is milling, cutting, drilling, and drilling the composite parts. As you go to the far left, the NDI and industry testing. This is the echo, pulse echo transmission, utilizing water to start NDI and test the composite part. And then the far left corner is for shipping. So the middle area, the gray area, we have a crane and we have all this, geometric measurements, CMM machines, and the small painting shop for small painting. So it's really a full spectrum at the start, and there's also a plan room to grow. But this is kind of what I wanted to explain or talk about this factory in the Kingdom of Saudi Arabia to meet the Vision 2030. So developing aerostructure parts. Is this a strategy will support the Vision 2030 and will create employment creation, local capability development, which is very much needed in the kingdom to manufacture composite parts, and also economic contribution. It will definitely contribute to the GDP. So this is kind of the factory's goal and projection. And the next one, I got to touch a little bit on the market. As you know, metal and composite are now coming, together. As metal, the start of making composite. Metallic parts. Now, as composite coming in place, as you can see, the growth rate of the composite is a bit stronger than the metal. However, stronger still there. Metal still there, and what I think launched the composite manufacturing for airplane is the 787 and A350, and there's I believe there's multiple business jets that come in the market. As you can see, the growth for that is pretty high. It's surprisingly exceeding the commercial jet. So, but it's coming to the composite knowledge and technology is coming to the market faster than we think. And I always say it's not a matter of using composite; it's a matter of when you're going to use composite. So there's no running away from it. The mechanical property, the physical property, the chemical property that this material brings to us as an industry guy, as an engineering guy, it's great. Environmental control, temperature, stiffness, we can play with that. Materiologists can do that. I'm not a materialogist. However, as a design engineer, I always look out for new materials, new processes, new manufacturing to make the part. And I'm an end user, I consider myself, not a scientist in materials, but I do need the materials to reach my goal for the industry. So as you explained, it's brief about designing composite aircraft structure part.
Sorry,
I hope I reach us.
Sorry, you have 2 minutes left.
Okay, great, thank you. So I will leave that. Thank you for the time and the opportunity, and I'll leave that for question.
Okay, excellent. Thank you, Dr. Bakhsh. So we have a question from Azam. In the case of hand layup process, let me read this. In case of how do you control the distribution of resin between parts in the hand layup process?
Okay, that's a good question. With the hand layup process, it's already pre-impregnated material. So the carbon is already pre-impregnated the resin in it. So you do not control the resin really. However, when you do your bagging and you do your control, you do your bagging and you put it in an autoclave, it's really important how you design the part. Believe it or not, designing the part is if you can have resin rich or resin starved in some area. So you're really controlling the resin. It's up to the pressure control in the autoclave when you do the bagging, and then your gelling time as your resin gelling and start getting harder and stiffen and getting interacting with the yarn, with the carbon. That's very important. How you design the part and how you bag the part and how you do something called tacking. When you start doing the first layer and the second layer, we do something called tacking. You tack the material together. You try to compress the material together to make sure there's no air bubble or gaps in between the two layers of material. So it's really it's not a resin infusion we're talking about with these machines or the hand layup. It's more of the thermoset, not a dry fab.
Okay, thank you. So we are now at the 4:50 already. So we need to move on to next speaker. Thank you. Oh, would you like to ask, Jill?
Yeah, thank you, Arif.
Yeah. Okay, just quick question.
Thank you, Arif. I think I have an echo here.
You need to switch off the speaker on the main speaker in the room.
Yeah. Let me check something. I just wanted to ask a quick questions about what are the systems that you are planning to develop in the new manufacturing facilities that you are building now. So is it system that you are going to build that are subcontract with other international companies, or you are going also to design some systems in Saudi Arabia for light aircraft or things like this? You're on mute, Muneer. Unmute.
Please unmute.
Okay, so it's not really designing it. It's more we're going to start with the manufacturing part of things, and then we're going to move into the design. So most likely, a product already being designed, and then a joint venture with companies in the kingdom. And this factor will be in the localization category. So if you want to come and do business in Saudi, I would like to provide any products to the kingdom, and your product can be made in this factory. We can manufacture it for you. But the design phase, inshallah, will be the next one.
Thank you, Muneer. Thank you.
Thank you. Thank you very much, Dr. Muneer.